In the closing hours of December 31st on the cosmic calendar, a visitor from the depths of space passes through our neighborhood. We humans, who appear in this calendar only moments before midnight, have been gifted with the extraordinary ability to witness something that has been journeying through the galaxy for perhaps millions of years, traveling across what would represent entire days, perhaps weeks, on Carl Sagan's elegant timeline of cosmic history. This visitor is 3I/Atlas, the third confirmed interstellar object ever observed by our species, and it invites us to contemplate one of Sagan's most powerful educational tools, the cosmic calendar, with fresh eyes and renewed wonder. Carl Sagan created the cosmic calendar to help us grasp what is fundamentally difficult for the human mind to comprehend: the vast age of the universe and our extraordinarily recent arrival within it. By compressing 13.8 billion years into a single calendar year, Sagan gave us a framework for humility. The Big Bang occurs at midnight on January 1st. Our Sun and Earth don't form until September 1st. The first stirrings of life on Earth emerge on September 21st, and all of recorded human history, every civilization we know, every book ever written, every person we've ever heard of, occupies only the last 10 seconds before midnight on December 31st. We are, as Sagan taught us, newcomers to the cosmos. If you find yourself moved by this perspective, if you wish to continue exploring the universe with the same sense of wonder that drove Carl Sagan throughout his life, join us on this journey by subscribing to this channel. Help us spread this cosmic perspective by sharing these explorations with others who look up at the night sky and ask the deep questions. Sagan believed that we are a way for the cosmos to know itself. Every person who embraces that idea continues his legacy. But what does 3I/Atlas teach us when we place it within this framework? The answer reveals something profound about time, motion, and the patience of cosmic processes. On July 1st, 2025, the Atlas Survey Telescope in Rio Hurtado, Chile detected a faint streak moving against the background stars. Within days, astronomers realized they were observing something extraordinary. The orbital calculations revealed an eccentricity of 6.137, far greater than any object bound to our Sun could possess. This was no comet born in our solar system. This was a traveler from interstellar space, moving with a hyperbolic excess velocity of 58 kilometers per second relative to our Sun. To put this in perspective, that's 130,000 miles per hour, the fastest velocity ever recorded for an interstellar visitor, exceeding even the remarkable speeds of 1I/Oumuamua and 2I/Borisov. The James Webb Space Telescope and the Hubble Space Telescope have both turned their instruments toward this visitor, capturing images of its dust plume and measuring its composition. Spectroscopic observations from the James Clerk Maxwell Telescope detected hydrogen cyanide in its coma, revealing chemistry from another star system, molecular signatures formed in conditions we can only imagine. This is observational science at its finest, the kind of patient, rigorous investigation that Sagan championed throughout his career. Consider the mathematics of cosmic time. In Sagan's cosmic calendar, 1 day equals 37.5 million years. 1 hour equals 1.56 million years. 1 minute equals 26,000 years. 1 second equals 430 years. By these measures, all of human civilization, from the earliest agricultural settlements to the cities of today, occupies approximately 23 seconds, the entire span of our species, Homo sapiens, perhaps 10 minutes. But 3I/Atlas has been traveling through space for a duration that likely spans multiple days on this calendar, perhaps even weeks or months. If we calculate backwards, assuming 3I/Atlas has been moving at its current velocity of 58 kilometers per second through interstellar space, not accounting for gravitational perturbations from passing stars or dense nebulae, we can estimate the distances it has crossed. 58 kilometers per second translates to approximately 1.8 parsecs per million years, or roughly 6 light-years every million years. Over 10 million years, a mere 8 cosmic hours on Sagan's calendar, this object could have traveled 60 light-years. Over 100 million years, just 2.5 cosmic days, it could have crossed 600 light-years. a significant fraction of the distance between spiral arms in our galaxy. We don't know where 3I/Atlas originated. As astronomer David Jewett from UCLA noted, projecting its trajectory backwards through the gravitational chaos of our galaxy is like trying to determine where a rifle bullet started after glimpsing it for a thousandth of a second. But we know it has been journeying for cosmically significant timescales. This is the astronomy that fascinated Carl Sagan. Numbers that force us to confront our temporal insignificance and our extraordinary fortune to exist in this particular moment, when we possess both the technology to detect such visitors and the intellectual framework to understand what they represent. Sagan wrote extensively about interstellar space in his books Cosmos and Pale Blue Dot. He understood that space is nearly empty, that the distances between stars are so vast that objects drifting through the darkness might wander for billions of years without ever encountering another solar system. He wrote about the Voyager spacecraft, which he helped design, carrying messages into interstellar space with the understanding that they might circle the center of the Milky Way galaxy, essentially forever, perhaps 5 billion years or more, without ever being found. The Voyagers will become, in their own right, interstellar objects like 3I/Atlas, artificial ambassadors drifting through the cosmic ocean long after our civilization has either transformed beyond recognition or vanished entirely. But Sagan also understood statistics and probability. If 3I/Atlas exists, if we have now detected 3 interstellar objects within the span of just 8 years, first Oumuamua in 2017, then Borisov in 2019, and now Atlas in 2025, then our galaxy must be filled with billions upon billions of such wanderers. Astronomers calculate that the spatial number density of objects like 3I/Atlas must be approximately 10 to the -3rd per cubic astronomical unit. This implies a vast population of interstellar nomads, most of them small, dark, and invisible to us, crossing the spaces between stars on journeys measured not in years or centuries but in millions of years, in cosmic days and cosmic weeks. This is where Sagan's skeptical mind would ask us to pause and think carefully. The appearance of an interstellar visitor does not imply alien technology or intelligent design. Extraordinary claims require extraordinary evidence, a principle Sagan articulated more clearly than perhaps anyone in history. The evidence we have shows 3I/Atlas behaving exactly as we would expect a comet to behave, outgassing as it approaches the sun, exhibiting a dust tail, showing spectroscopic signatures consistent with volatile ices and organic molecules. There is no signal, no anomalous acceleration that cannot be explained by natural outgassing, no reason to invoke anything beyond the physics we understand. When we observe 3I/Atlas through Sagan's lens, we see not a mystery that defies explanation, but a natural consequence of galaxy formation and stellar evolution. Stars form from collapsing clouds of gas and dust. Planets and smaller bodies coalesce from the remaining material. Some of those bodies are ejected through gravitational interactions with giant planets, flung out into interstellar space where they drift for unimaginable spans of time. Eventually, by pure chance, a tiny fraction of them pass through another star system. We are witnessing one of those rare moments, and we should celebrate it for what it actually is. A confirmation of our models of how planetary systems evolve and interact. The deeper questions that Sagan would pose are philosophical. What does it mean that 3I/Atlas has been traveling through space since before anatomically modern humans existed on Earth? If this object began its journey 100 million years ago, dinosaurs still walked our planet. The Rocky Mountains had not yet formed. The continents were arranged differently. No hominid had yet stood upright and looked at the stars with comprehension. And yet, this small chunk of ice and rock and organic molecules was already moving through the darkness, passing star after star, crossing regions of space we can barely map even now with our most sophisticated instruments. It carried with it chemistry from its birth system, perhaps from a star that no longer exists, perhaps from a planetary system that has been disrupted or destroyed. It is, in a sense, a message in a bottle, though not one placed deliberately. It tells us that matter moves through the galaxy, that the elements forged in stellar cores are redistributed across vast distances, that our own solar system is not isolated, but connected through these wandering ambassadors to the broader galactic ecosystem. Sagan wrote in Pale Blue Dot that our planet is a lonely speck in the great enveloping cosmic dark, that in our obscurity and in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbour life. There is nowhere else, at least in the near future, to which our species could migrate. This was not pessimism on Sagan's part, but clear-eyed realism combined with a call to responsibility. If we are alone, if life is rare or even unique to Earth in this corner of the galaxy, then we bear an extraordinary obligation to preserve what we have, to treat this pale blue dot with the reverence it deserves. But 3I/Atlas also reminds us that we are not entirely isolated. We are embedded in a galaxy where matter flows, where objects cross the spaces between stars, where what happens in one stellar nursery eventually spreads across parsecs and light years. We are part of a larger system. Consider how recently we have gained the ability to detect and study such objects. The Atlas telescope system that discovered 3I/Atlas. The Asteroid Terrestrial Impact Last Alert System only became fully operational in the last decade. The James Webb Space Telescope launched in 2021. The Hubble Space Telescope, which has now observed all 3 known interstellar objects, was repaired and upgraded multiple times throughout its service life, becoming more capable with each astronaut servicing mission. Sagan died in December 1996. He never saw Hubble's deep field images, never witnessed the detection of thousands of exoplanets, never knew that we would within 3 decades of his death be routinely observing visitors from other star systems. But he predicted this moment in spirit, if not in detail. He knew that our technology would improve, that our surveys would become more sensitive, that the universe would reveal more of its secrets to patient, careful observation. In the 1980 Cosmos series, Sagan spoke about the possibility of interstellar visitors, about the statistical likelihood that comets and asteroids must be ejected from planetary systems and set adrift. He understood the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them. He would have been fascinated by 3I/Atlas, not because it represents aliens, but because it represents exactly the kind of natural cosmic process he spent his career explaining and celebrating. Let's return to the cosmic calendar and place ourselves in proper perspective. Midnight on December 31st is approaching. In the last 10 seconds before midnight, humans have built cities, developed writing, created art and music, formulated the laws of physics, split the atom, traveled to the moon, and sent robotic emissaries to every planet in our solar system and beyond. In those same 10 seconds, we have also fought countless wars, driven species to extinction, and altered the chemistry of our atmosphere in ways that threaten the stability of our climate. Sagan would ask us which path we will choose in the seconds that remain, in the next cosmic year that is beginning. Will we use our intelligence to continue the journey of understanding, or will we squander our 15-billion-year heritage in what he called meaningless self-destruction? 3I/Atlas offers us a moment to pause and reflect on these questions. This object predates our entire civilization. It has been moving through space while empires rose and fell on Earth, while species evolved and went extinct, while continents drifted and mountains eroded. It has witnessed, in its blind journey, the passage of cosmic time on scales we struggle to internalize. And yet here we are, standing on our pale blue dot at the end of the cosmic year, with instruments sensitive enough to detect this visitor, minds capable of understanding what it represents, and the philosophical framework, gifted to us by thinkers like Carl Sagan, to appreciate both the science and the poetry of this moment. We are made of star stuff, Sagan taught us, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies. All were made in the interiors of collapsing stars. We are a way for the cosmos to know itself. And when we observe 3I/Atlas, when we measure its spectrum and calculate its trajectory and contemplate its millions of years' journey through the galaxy, we are fulfilling that cosmic purpose. We are the universe examining a small piece of itself, matter arranged in such a way as to be capable of wonder and understanding. The patience of cosmic processes is humbling. 3I/Atlas does not hurry. It moves at 58 kilometers per second, which sounds fast by human standards, but at cosmic scales, it is almost leisurely. The galaxy rotates at approximately 220 kilometers per second at our position in the spiral arms. Stars are born, live their lives, and die on timescales of millions to billions of years. Mountains rise and erode over tens of millions of years. Even light, the fastest thing in the universe, takes years to cross the distances between nearby stars and tens of thousands of years to cross the galaxy. Everything we see in the night sky is ancient light, photons that left their source long before we were born, in many cases long before our species existed. We live in a universe that operates on timescales that dwarf our individual lives and our collective history. This is the perspective Sagan wanted us to absorb, not to feel insignificant in a nihilistic sense, but to understand our place, to feel the appropriate humility, and to recognize that we are participating in something far larger and older than ourselves. What would surprise even Sagan, I think, is how quickly we have moved from detecting our first interstellar object to observing our third. The pace of discovery is accelerating. Our survey telescopes are becoming more sensitive. Our data processing algorithms are improving. Within the next decade, we will likely detect dozens or even hundreds of interstellar objects. We will begin to characterize the population statistically. We will learn about the diversity of compositions, the range of sizes, the distribution of velocities. We will start to piece together the story of how planetary systems form and evolve across the galaxy, not just from observing exoplanets, but from studying the debris that gets expelled from those systems. This is the golden age of astronomy that Sagan dreamed of, where observation and theory work together to reveal the cosmos in ever greater detail and clarity. But the most important lesson, the one Sagan returned to again and again, is that all of this knowledge, all of this cosmic perspective, should inform how we treat each other and how we treat our planet. Look again at that dot, he said, speaking of Earth as photographed from beyond Neptune by Voyager 1. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph, they could become the momentary masters of a fraction of a dot. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To Sagan, it underscored our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. 3I/Atlas will reach its closest approach to the Sun, its perihelion, on October 30th, 2025. It will warm, its ices will sublimate more vigorously, and then it will begin its journey back out into the darkness, accelerating as the Sun's gravity slingshots it toward interstellar space. Within a few years, it will cross the orbit of Neptune. Within a few decades, it will leave behind even the scattered disk and the Oort cloud. And then it will spend millions of years, perhaps hundreds of millions of years, traveling through the space between stars until, by unimaginable chance, it might someday pass through another stellar system, giving some other civilization, if any exist, the same fleeting opportunity to observe a visitor from far away. It is part of the great galactic recycling system, matter in motion, chemistry spreading across the cosmos, a process that has been happening since the first stars ignited more than 13 billion years ago, back in early January on the cosmic calendar. We are so fortunate to live in this moment, in these last seconds of the cosmic year, when we have the tools and the knowledge to see such wonders. We are the legacy of 15 billion years of cosmic evolution, Sagan reminded us. We have a choice. We can enhance life and come to know the universe that made us, or we can squander our 15 billion year heritage in meaningless self-destruction. What happens in the first second of the next cosmic year depends on what we do here, now, in these closing moments of December 31st. Carl Sagan's legacy lives in every person who looks up at the night sky with wonder and curiosity, in every scientist who asks the deep questions about where we came from and where we are going, in every educator who helps others see the universe more clearly, and in every citizen of Earth who takes seriously the responsibility to protect our pale blue dot. He taught us that science is not just a body of knowledge, but a way of thinking, a way of skeptically interrogating the universe with a fine understanding of human fallibility. He taught us that the cosmos is within us, that we are made of star stuff, that we have evolved from stardust and will return to stardust, and that this should fill us not with despair but with wonder and connection. As 3i/Atlas continues its journey, carrying with it the chemistry of another star system, crossing distances measured in cosmic days, while we live out our cosmic seconds, let us remember what Sagan wanted most for humanity. He wanted us to survive our technological adolescence, to become a wise and long-lived civilization, to spread life and consciousness beyond Earth not through conquest, but through careful ethical exploration. He wanted us to be worthy of the cosmos that created us. He wanted us to preserve the only world we know that can harbor life, to treat it as the sacred trust it is. And he wanted us never to lose our sense of wonder, never to become jaded or cynical about the extraordinary fact of our existence in this vast and ancient universe. Continue exploring the cosmos with us. Seek out knowledge, embrace uncertainty, demand evidence, think critically, and never stop looking up at the night sky with the recognition that you are part of something magnificent. Help spread this message of science and wonder so that more people can experience the cosmic perspective that Carl Sagan spent his life sharing. The universe is vast and old, and full of wonders we have barely begun to glimpse. Our moment in cosmic time is brief, but it is ours, and what we do with it matters. We are a way for the cosmos to know itself. Let us fulfill that purpose with wisdom, compassion, and an enduring sense of awe at the privilege of being alive and aware in this particular corner of space and time, able to witness visitors like 3i/Atlas and understand what they mean. As Sagan might have said, we are privileged to live in this universe, and it is our responsibility to understand it and to cherish the brief moment we have to contemplate its wonders and our place within them.